Good day, guys. Welcome back to the King History class. And welcome back to another series in integration. Now, as for our last series, we looked at different sub-headings under integration. In our last class, we looked at the 5 important rules in integration. Now, I want to apply that 5 important rules to solving some questions in integration. Now, for today's question, we have basically 3 questions. We have number 1 to be integral 4x cubed minus 1 over x to power 4 minus x plus 2 dx. And we have question 2 and 3. Now, in this case, using one of the 5 important rules that we discussed in our last class, let's see how we can efficiently apply it to solving these questions in integration. Now, for the first one, looking at the question, we have to what? Y equals integral 4x cubed minus 1 equal what? X is power 4 minus x plus 2 dx. Now, trying to solve this, trying to integrate this question, will make you look at some of the rules you can apply, or some of the things we have taught earlier, to solve this question. Now, but what you can apply here best is what? Since it has a denominator, differentiate this, okay, and compare it to the same thing with the numerator. So we know what to do. On differentiating our denominator, we have that what? We have that 4x is power 3 minus 1. Differentiating 2 here is 0. So we have a denominator when we differentiate to what? 4x cubed minus 1, which is the same thing as what? Our numerator. In which case, the differential of this automatically will be what? Log of what? Of our denominator. X is power 4 minus x plus 2, then plus what? C. Since according to number 5 important rules in integration, you will differentiate this denominator and the same thing as numerator. The answer will be in what? This form, log form or ln form, or what? The denominator plus what? Plus C. So that's for number 1. For number 2, number 2 is what? Y is equal to what? Integral of what? 2x plus 3 or is equal to what? 10 dx. Now, in this case, it seems like what? A function question in integration, which I'm going to say what? Let u equals what? 2x plus 3. In which case, my y automatically becomes what? Integral what? U raised to power 10 dx. Now, y is also what? Integral u raised to power 10 dx. Now, from this point where we said our u is equal to 2x plus 3, we have the u dx to be what? To be 2. So if u dx is 2, it implies that what? Dx is what? Dx is what? The u over 2. Dx is the u over 2. Okay, so that's from this point. Now, let's go back to y. This becomes what? Y is equal to what? Integral u raised to power what? 10. Let's change this one to the x. Because the x is what? The u over 2. That becomes u raised to power 10 du over 2. We are integrating my y. I'm going to have that what? I'm going to have that as u raised to power what? 10 plus 1. Okay? Now, that becomes what? Y is equal to what? Bring 1 over 2 outside of the integral as to what we discussed earlier in our last series. This is a constant. 1 over 2 is a constant, so we can bring that back of the integral. U raised to power 10 du. So now integrating this becomes what? 1 over 2 into what? U raised to power 10 plus 1. You are what? 10 plus 1. Okay? Plus what? Plus C. Now, in that case, my y is going to be equal to what? 1 over 2 u raised to power what? 11 over what? 11 plus what? C. Finally, I have that what? U raised to power what? 11 over what? 22 plus C. When my u is what? My u is 2x plus 3. I'm going to have my y to be equal to what? 2x plus 3 all raised to 11 over 22 plus C. And for number 3 question, we have it to what? Integral dx over what? Square root of 12x minus what? 9x squared. Now, in this case, looking at this question, is the same thing as 1 over all these dx. Okay? Now, in which case, to solve this question, we apply what we applied in number 1 question here by saying what? Differentiate this denominator. You cannot get 1 because the numerator here is what? Basically 1. You cannot get 1 here. But now looking at it, it looks like that of sine or cos function. Okay? Where for that function, we have it as 1 over a squared plus s squared. Okay, for sine function, we have it as 1 over square root of a squared minus s squared. Where if you integrate, I'm going to get 1 over a sine inverse of x over a plus c. And for cos, we have that like that. So, that is the way this question looks like. So, it means I have to transform 12x here to something of raised power 2. Okay, where 9x squared is already the same as 3 squared x squared in that case. So how can I transform 12x to something of some raised power 2? Now, to get 12x by saying what 4 times 3, 12. Where 4 is same as 2 raised power 2. So in which case I can now say that it is same as dx over integral dx over square root of 2 squared. Now, what can I add to 2 squared to get all this back? Okay, so that it will be minus or plus something all squared to get what? All this back. Now, after solving, I have what? 2 squared minus what? Minus 3x minus 2 all squared. This should get this back. To confirm, what does what? This is 4 minus. Now, expand this becomes what? 9x squared minus what? Minus 6 minus 12x in that case plus 4. Expanding this becomes what? 9 squared minus what? 12x plus what? Plus 4. Now, expand that becomes what? 4 minus 9x squared plus what? 12x minus what? 4. Where 4 cancels out, I have that what? 12x minus 9 squared. So, this one, that becomes what? Square root of 2 squared minus what? 3x minus 2 all squared dx. Where this is the same as that. Now, from here, this looks like that of sine. So, in which case, automatically, I have the integral of this to what? Sine, I have it as what? 1 over a sine inverse of what? X over a plus c. This is the form it's going to take. Okay, according to one of our 5 important rules in solving questions in integration. That becomes 1 over a here is what? 2 sine inverse of what? X is what? 3x minus 2 over a here is 2. Then that will be plus c. So these are some questions using the 5 important tools we mentioned in our last series in integration. If you not subscribe to my channel, please also subscribe and put a notification bell so you can see the notification when we upload